Once we've established that an equation is a function, then we can perform algebraic operations on these functions. We're looking at five main types of operations to where we can take the sum, the difference, take the product, or take the quotient, or take a composition of two or more functions. If you're taking the sum of two functions, f plus g, we're simply adding these two functions together. Finding the difference, we're subtracting the two functions. Product, we're multiplying the functions. Quotient, dividing the functions. And for the composition, we'll spend a little more time on that, to where you're taking the composition. So we're evaluating, if we're taking the composition of f circle g, we're evaluating the function f at the function g. We'll see how that works. And we'll see how all five of these operations work using the following example. We're letting f of x equal 2x minus 1 and g of x equals x squared plus 1. And let's go through all five operations. So first, let's find the sum, f plus g. We said we're doing this by simply adding these two functions together. And combine like terms if you can combine like terms. Here, and I'm also going to write this in descending order. Typically, we write polynomials in descending order with the highest power first and the powers decreasing from term to term. So I'm going to write this x squared first, the 2x next, and then I can combine the terms -1 plus 1, which actually cancel out. That's plus 0, so I don't need to write that. So f plus g is x squared plus 2x, which is also a function. And the domain of f plus g will be the intersection of the two domains of f and g. Now, in this case, f and g are both polynomials, so the domains are all real numbers, which means that f plus g will have a domain of all real numbers. So finding the difference between f and g would follow the same steps. F minus g, we're taking f and we're subtracting g, x squared plus 1. Here you need to be careful when you're subtracting. When you subtract the function g of x from f of x, this minus sign belongs to everything in this function g. So we can think of this as distributing. Right? We're distributing this subtraction operation. So when we distribute the minus, we've got minus x squared minus 1. Now, that's an easy mistake to make, is to forget to distribute this minus sign. Make a special note there so that you remember to do that in the homework and on the test. Once we distribute the minus, now we can combine like terms, writing this in descending order with the negative x squared first, 2x would come next, and then combine the like terms. -1 plus a -1 is a -2. Right? So this is negative x squared plus 2x minus 2 is my function f minus g. And again, domain is all real numbers. And next, let's take a look at the product of f and g. Taking the product, I'm multiplying the function 2x minus 1, that's the f of x, by the function g of x, which is x squared plus 1. And if you can simplify this, simplify it as much as you can. In this case, we have a product of two binomials, and we can apply FOIL here. We're distributing each term in this f of x function. You may use the FOIL, right? First times first, then multiply outside, and then multiply the insides together, and then multiply last times last. So 2x times x squared is 2x cubed. 2x times 1 is 2x. and then distributing the negative 1, that's the outside and last terms. Negative 1 times x squared is negative 1x squared, and negative 1 times a positive 1 is a negative 1. Combine like terms, if you have any. In this case, we don't have any like terms because all of our exponents are different. But I can arrange this in descending order by writing this as 2x cubed minus x squared plus 2x minus 1. Now, when you're typing this into WebWork or whatever online homework system that you have, the order of how you're writing your answers does not make a difference. You do not have to enter your answers in using descending order. You can type it in any order that you want in that WebWork or whatever homework system that you're using should recognize that. All right, and then the quotient of f and g, right? F divided by g, we are dividing f. It is 2x minus 1 by the x squared plus 1. And if you can simplify any, you can simplify. Most of the time when you're dividing, there's not going to be any simplifying that you can do. The only thing you could try is if you can factor the numerator and denominator, maybe you can cancel some common factors. In this case, 2x minus 1 is not going to factor. Neither will x squared plus 1. X squared plus 1 is a sum of squares. That will never factor in the real number system. So we'll leave this answer as it is. We'll leave that as it is. And if you're being asked about the domains, right, we said that the domain of your sum, your difference, even the product is the intersection of the domains. For the quotient, you have to go back to checking the two restrictions, right, the things that we can never do in mathematics. We can never divide by 0. We can never take the square root of a negative number. In this case, if you are looking for the domain, right, you're looking to see, are there any times where x squared plus 1 could equal 0? I remember what we did with in a previous video, we set that x squared plus 1, the denominator, not equal to 0. And we tried to, and we solved for x, and that gave us the domain, and we would write that in interval notation. In this particular case, though, x squared plus 1 can never equal 0. Right? X squared, if you square any number, that's always going to be positive. If you add 1 to it, that's still going to be positive. So x squared plus 1 can never equal 0. So the domain for the f divided by g is also all real numbers in this particular case. All right, so we went through sum, difference, product, and quotient. The only thing we have left is this composition. And I'll come up here for the composition, f circle g. All right, we said this is where we are evaluating f at g of x. In other words, we're taking our function g of x and we're plugging it into the function f of x. So in other words, wherever we see an x in the f of x, we're going to replace it with what g is equal to. All right, so we're taking this x right here and we're replacing it with x squared plus 1. So this would be 2 times the g of x, x squared plus 1 minus 1. And again, simplify, if you can, distributing the 2. 2 times x squared is 2x squared. 2 times 1 is 2. And I can combine the like terms 2 and negative 1. That will give us 2x squared plus 1 for f of g. And just one more note here. This is f of g, right? I'm plugging g into the function f. I could go the other way around and evaluate g of f. This is g circle f. This one is the exact opposite, to where instead of plugging g into f, we would be plugging f into g. wherever we see an x in the g function, we would replace it with this 2x minus 1. And my point of working this out here is that f of g is not necessarily the same as g of f. You would expect to get two different functions here. So I'm replacing x with the 2x minus 1. So 2x minus 1 squared plus 1. Simplifying here, we can see that these are two very different functions. If I'm squaring out a binomial, students tend to have trouble with this. So if you have trouble with squaring it, just write it out twice and use FOIL. Okay, but there is a shortcut for squaring the binomial. To square the binomial, you square the first term. 2x squared is 4x squared. You square the last term. Negative 1 squared is a positive 1. But students forget this middle term. There's a middle term in here. That middle term is found by multiplying the first term times the second term and then doubling it. 2x times negative 1 is negative 2x. If you double that, if you multiply by 2, that would be a negative 4x. And so 2x minus 1 squared is 4x squared minus 4x plus 1. And then we've got this other 1 out here that we should not forget about. And combining those like terms, our function g circle f is 4x squared minus 4x plus 2. We can see that these are different functions. All right, so you do not get the same functions if you switch those around. Be careful with that. All right, so those are our 5 operations of functions, and we're going to see how those can be applied for business applications here in the next video, as well as moving on into the remaining sections that we have in chapter 2.